So the law of sines proportion says that you have a side length A over the sine of the angle across. Something that bothers me about this that I didn't notice until just now is that you use small letters to denote side lengths, not small, lowercase letters for side lengths, uppercase letters for angles. So we need to change all these to uppercase. Not that you can really tell with the C. So those go together. Then this side length B over the sine of its angle, opposite angle, and the side length C, which corresponds with the sine of C and its opposite angle. Now, in order for you to be able to use the law of sine, you obviously only have to have two of these going on, not all three. Law of sines, as you can see at the bottom of this, can be used to solve triangles where we know two angles and a side. So either angle, angle, side, or angle, side, angle. Or if you are given two sides and a non-included angle. You have to be careful here. Do you know why you have to be careful here? What is that? Is that a triangle congruence? It's like hypotenuse leg. We are going to talk about, that's called the ambiguous case of law of sines. Sometimes it's going to work, sometimes it's going to not, sometimes it's going to have two answers. Two answers. Yeah. Sometimes it's going to have two. So we'll look at that in a minute. We're going to focus on these two at first. So anytime you have angle, angle, side, or angle, side, angle, law of sines is going to work. So we're going to open our foldable and twist it around and see that. Okay. Example 1. Given two angles and a side, so we have angle, angle, side, we are going to solve this triangle. When it says solve the triangle, it means we want every piece that is missing to be found. It says first, find the third angle. You know how to do that without even the law of sines. So let's find angle A. How do we find the measure of angle A? Yeah, 180 minus 107 minus 25. Somebody told it to me. What is it? 48 degrees. All right, that's the first thing we're going to do. 48 degrees. Great. I'm having a problem making it so you can see it today. All right, so next it says find the sides using the law of sines. We need to find A and we need to find C. I'm just going to go in alphabetical order. You're going to find A first. That means if I need to find A, I'm going to use this because it is opposite to the side length A. That 48 degrees is opposite to the side length A. What is the only other side length we know? B. And it corresponds with what? Angle B, which is 25. That's what we're going to use to find A then. Zoom in on that a little bit. Okay, so looking at our law of sines proportion, I have A, which we don't know what is. Zoom back out. A over the sine of A, but what is A? The angle A is 48 degrees. Equals B. What is this segment B? Over the sine of B. What is the angle B? That is how I set up law of sines. I'm then going to cross multiply. I am not going to round till the very end. I don't think it tells me what to round to. If it does not tell you, I want you to do 4 decimal places, even though you might think that seems like a lot. Do it anyway. Alright, I'm going to cross multiply. So A times sine of 25 equals 15 times sine of 48. You do not need to type anything in until you get A by itself. Divide by the sine of 25. So, A equals 15 sine of 48 over, or divided by, sine of 25. Type that in, get A to the nearest 10,000, which is, 4 decimal places. Make sure it's in degree mode. 4 decimal places. You got what, 26? Somebody get anything different? I got 13.7477797. Oh, yeah, you see this? I didn't close the parentheses. People do that all the time and get the wrong answer. You're right. I just wanted to show you that I see that all the time. If you put it all in at once and don't close that parenthesis, you're going to have a problem. Okay. So just be careful. 26.3765 is correct. That's correct. So you're typing in this. If you didn't get that, make sure you put the parentheses where they go. Or your calculator's in degree mode. We're going to do another one. I'll make sure that you've got another. We're going to keep going. We're going to use this one to solve for C now. Something that is nice when I keep doing these over again, I've got to find C now, but no matter what, I'm going to take what I know from this proportion. I knew that I had 15 over sine of 25. That's the B side and angle. I'm now going to set up the other part with C. So I don't know C, but what is its angle measure? So sine 107. Now that that's set up, I want you guys to cross multiply and find C. Okay, you cross multiplied. And when you cross multiplied, what did you have? C times the sine of 25 equals 15 times the sine of 107. Okay, and then what'd you do? What was C equal to? Because I'm not going to write that back down again. You don't have to after that step. 33, not 30. 33. So you typed this in your calculator. C is the longest side length because it's across from the longest angle. Did it work out that way with our value here? Is that the longest side? It did. We're good. If you have angle, angle, side, or angle, side, angle, they all work out this way. You do have to, when it says solve the triangle, find every single piece. Okay? Alright, we're going to move it to example 2. Go ahead and find the third angle. What's missing? Okay. I'm talking about the angle. We got to find the angle first. Find the missing angle. It's what? 35? Alright, now what sides are missing? So find B, find C, using the fact that the angle A is 35 degrees. You're going to match up side length over the sine of the angle. Side length over the sine of the angle. I want you to set them up. Try us all at those. Okay, so we have A, so you said 30 over sine 35, which is what we're going to use for all of them. We're also going to use that for C. Do you know why we use that one again for C instead of using B? It's not a decimal, it's not rounded, so we always go back to the one we had originally. Okay, so B then is B over sine of what? while I'm at it, let's set this one up too. It's c over sine of, okay, cross multiply, and you get 30 sine 30 equals b sine 35. Then what'd you do? And you plugged this in your calculator, correct? Okay, so what was b equal to? What? Okay. We don't have units. If we did, I would want you to put them, but we don't have any. Alright, similarly here, we're going to cross multiply, but you get 30 sine of 115 equals c sine of 35. Divide by sine of 35. Of course, that crossed out here. And you are plugging this in. What did you get for c when you plugged that in your calculator? I hope that's what you said. 47.4030. Okay. Alright, we are going to talk about the ambiguous case next. You need to open your notebook and glue this in. But before you do, we have skipped 13.4. But we are going to come back and do 13.4. It will take us less than half a day to do it, and that's why I'm skipping it for now, because we're going to do it and take your quiz on Friday. So, we are skipping 2 pages until Friday. So that means this goes glued on page 116. Glue this on 116. Then you can look at this and the example, but here's where you have 2 triangles in a minute. But we're going to work some of each. Which, like I said, in the ambiguous case, it's possible to have 1 triangle, no triangle, or 2 triangles. This breaks it down really well if you decide, hey, which one am I going to have? Alright, so, example 5. Given a triangle with a measure of A, which is 30, a side length 20, a side length of 16, we're supposed to find the other dimensions. So it says, use the law of sines to find the measure of B. So that's what we're going to do first. Now, I think they gave you this space right here to do that. I don't think that's enough room. So I'm going to find the measure of angle B down here. And I have to use the law of sines because I can't just subtract from 180 anymore. If you remember from just a second ago, the law of sines, we take, what is the only ones that we know both the angle measure and the side length? A, okay, so we're going to take A with the side length of 20 over sine of its angle, what's the angle A, equals, do we know B? B is 16. Do we know B's angle? So we put sine of B. That is the only difference in what we just did. We figure out what we don't know. We don't know the angle B. We are still going to cross multiply. We're going to have 16 sine of 30 equals 20 times sine of B. Again, it's not different yet. How do I get everything away from sine of B? Divide by 20. So 16 sine 30 over 20 equals sine of B. Do you remember what the inverse operation of sine of B is? Sine what? Sine -1, which literally is sine inverse. B equals, type this in, sine inverse, parentheses, it will give it to you when you say it, 16 sine of 30 over 20. Now, if I were you, I would type all that in at the same time. But if you do, you need to make a fraction on your calculator. Do you know how to do that? It's been a little while since you've had to. Do you remember what button to press to make a fraction? Alpha, stat plotter, alpha y equals 16 sine of 30 over 20. That guarantees you don't have that rounding error problem. We are going to round the angles to the nearest whole number. So you should have gotten 23.57, but what is that rounded to the nearest whole number? 24. If you did not get that, you need to make sure you have typed that in correctly. So I'm going to say the measure of angle B is about 24. Okay. So we're going to go up and fill this in. It says the measure of B, okay, we found that out, it's 24. If this has two possible triangles, the second option for angle B would be its supplement. What do you remember what supplement means? 180. What is 180 minus 24? Here's what this is trying to decide. It's saying this right here could be 24 or it could be 156. Now we got to think that through. So there would be nothing left for C. That means this one does not work. So wait, this does not make sense. The conclusion is there is only one triangle. So we don't even have to worry about the second one. It does not work. Because 156 plus 30 is over 180 to begin with. We don't even have extra room for C. So if this is actually 24, we can then move on. We can find the measure of angle C, and then later find side length C. They could have no answer, one answer like this 24, or two different answers. Because they can either make one triangle, or they could make two like this one did. Or it could be possible that it's like, you remember when we did the triangle inequalities and we said, hey, the side lengths could be this, this, or this? Well, it's possible that they're giving you something that's not a triangle anyway. So those are the options. Either it makes one, two, or no triangle. So this one makes one triangle. If the measure of angle B is 24 degrees, what is the measure of angle C? Or how do you find it? 106? Okay, how'd you find it though? Yeah, so 30 plus 24, which is, so that's not 106. I can't hear. Oh, okay. And I can't add or look at things either. Thank you, guys. 24, not 25. So it's 54, which is 126. We should all make sure that I know what I'm doing at this point. Okay, 126 degrees. Okay. What is the only thing still missing from this triangle? Side C. I need to do that just like I did a second ago, like earlier on the last foldable. So side C. I'm still going to use 20 over sine of 30 equals what? We don't know C. What is C's angle measure? So C, you have to find the angle measures before. Alright, now somebody remind me how to do that. Cross multiply. So 20 sine 126 equals C sine 30. Then what'd you do? type this in. 4 decimals on the sides. Yep. What'd you get? Point what? I think on your homework it tells you, so whatever it tells you go with, but otherwise, round the angles to the nearest whole, sides to 10,000. Alright, example 6. Like I said, there are a whole lot of these ambiguous case examples, but in the real world where you're solving these problems, not in the real world, but even in the world of mathematics when you're solving these problems, you don't see this ambiguous case that much. Okay. Example 6. Use the law of sines to find the measure of angle B. We're going to do exactly what we did just a second ago. Measure of angle B. What do we already know from this triangle, no matter what? We know angle A and the side A, so what do we set up? Equals, we're looking for 16 over sine of B. Then what do? So 16 sine of 30 equals 7 times sine of B. Does it matter if those are written in the other order? No, I don't know why I do it that way. Okay, now what? Divide by 7. So 16 sine of 30 over 7 equals sine of B. Then what? You guys aren't completely familiar with that yet. It's not multiply it by. It's okay if you said that. But it's take the inverse sine of, which is. Okay, then type that in. Somebody tell me what you get. Oh, okay. It says error. Well, did you know some of you just skip through the error? It'll tell you what's wrong. You know, the domain error it go to. It has something to do with the fact that this side length is now short. Look at the one that we had right up there. We also had 30 and 16, but our A was longer. That means whatever is going to be left for C, this is not going to be a triangle that's possible. Since this says error, there is no triangle possible. We need to stop there. We can't do anything else. What'd you say? Yeah, it's like undefined. So, the example 5 is where you have 1. Example 6 is where you have none. If you had to guess, what's example 7? We're going to have 2. Okay. We're always going to start these by finding a missing angle. There is an actual rule where you can look at the triangle and see, based on what the side lengths are, whether you're going to have 1, 2, or none. I always find it easier just to find the measure of the missing angle and then determine from there, but there is a way. I can talk about that later in a few minutes. Alright, the measure of angle B. What are we going to set up again? The A is 10 over sine of 30, they haven't changed that yet, equals 16, haven't changed that either, over sine of B. It's not different. Cross multiply. 10 sine of B equals 16 sine of 30. What are we going to divide by? sine of B is equal to 16 sine of 30 over 10. What do we do to find B? The inverse, sine inverse. Alright, somebody tell me what that is. 53 degrees. Since we have an answer, we need to see what the second one would be. You remember how we found out what the second one was? 180 minus 53. 127. Is it possible to have an angle measure of 127 and 30 in the same triangle? Okay. Then we have to do both. Here's what I mean by that. We are going to have to find the measure of angle C with this, the measure of angle C with this, the missing side length with this, and this. We're going to focus on this one first. Measure of angle C is just 53 plus 30, and then subtract that from 180. 53 plus 30 is 83, minus 180 leaves 97. Okay, how do you find side length C? Okay. I'm going to give you a minute to finish that. Before you finish that, what would be measure of angle C if B is 127? It's what? 23. So how would you find side length C if measure of angle C is 23? Yeah, the only difference is sine of 23. I want you to finish solving both of those. It is like doing two problems in one if it just so happens that the second B makes sense. You should have cross multiplied. What did you get for C when the measure of angle C was 97 degrees? 8509. Okay. How about C when the measure of angle C was 23 degrees? So this problem is the only one, and you'll probably only have one in your homework, where if it makes sense for this obtuse angle to be in that triangle, you will have to have two problems, which means on the worksheet I'm about to give you, you'll probably have to have an attached piece of paper. Glue this in on 117. The tile is the same. I'm passing out your homework.